minute. I'm having issues. Your champ's expectations for warm-up is you are at a level 0. That means you're listening only while you're working. If you need help, raise your hand and wait patiently. Your activity is you're reading, thinking, and solving, typing, drawing, whatever it is that you need to do. Your movement is to stay in your spot. Your participation is to stay focused on your work so that we can all be successful. Your warm-up, you should already have it open. Yes? Some of you have already started it. I think that's great. It says examples of light being reflected and light being refracted are listed below. Circle all the examples of light being refracted. A. While standing next to the lake, your image appears on the lake. B. A rainbow appears as light shines through a prism. C. A student places a pencil in a clear glass of water and looks at the side of the glass. The pencil appears to be bent or distorted. D. A man wears a safety vest with a reflective strip on it for added nighttime visibility. E. A microscope has an eyepiece lens that magnifies an image. And then number 2 says, in your own words, explain the difference between reflection and refraction. I am going to give you 3 minutes to circle and respond. Yes. Can you what? Yeah. Go. Have about a minute left. All right. Let's take a look at what we did. So, thumbs up, it's refracted, and we circle While standing next to a lake, your image appears on the lake. Thumbs up, refracted. Thumbs down, reflected. Thumbs up, refracted. Thumbs down. You are correct. You're not going to circle this one. B says a rainbow appears as light shines through a prism. A rainbow appears as light shines through a prism. Thumbs up, refracted. We circle it. Thumbs down, reflected. We leave it. Thumbs up, it is refracted. Good job. C, a student places a pencil in a clear glass of water and looks through the side of the glass. The pencil appears to be bent or distorted. Thumbs up, refracted. We circle it. Thumbs down, reflected. We skip it. Thumbs up, it is refracted. D. D. A man wears a safety vest with a reflective strip on it for added nighttime visibility. Thumbs up, refracted. We circle it. Thumbs down, reflective. We leave it. It is reflective. See that word? Reflective strip. E. A microscope has an eyepiece lens that magnifies an image. Thumbs up, refracted. Thumbs down, reflected. Thumbs up, refracted. Thumbs down, reflected. Some of you are like, I don't know where you are. It is refractive. We are going to circle it. In your own words, explain the difference between reflection or refraction. In your own words. Anybody got anything they want to share? You want to just write something? Angie. Oh, come on, be bold. Come on. What's the worst that can happen? You're wrong? I'm wrong all the time. No. Jeremiah. Oh, well, that's correct, but it wanted you to circle all the examples that light is refracted. You circled all of them? You were only supposed to circle those? B, C, and E are all correct. Those are the circles? Okay, but now I'm looking at number 2. What's the difference between reflection and refraction? Okay, that's a lot of words. I'm not writing on that. Addison. Refraction is when something looks bigger or smaller. Listen. Refraction is something looks bigger or smaller. Now, are you necessarily writing what I'm writing? I have to rewrite it all over again. You're not. You are only writing this if yours is 1, wrong, or you did nothing, right? But if you have something there, then you may just like add a word or 2. But don't rewrite the whole thing. So, Good words. Good words. I am going to give you, we're going to start running out of time. I'm going to give you 2 minutes to finish writing this and submit, save now, and then open up today's lab. Set a timer for 2 minutes. Guys, I hear people saying shush, so clearly somebody is talking and nobody wants to hear it. What is today? What is today? It's Wednesday. So what do you look for? Wednesday. All right. I'm going to see, here, let me delete this. We're going to move on to the lab. But I am going to see if a couple of things that need to happen so that students online can see what's going on. I am going to see if I can shrink this. I'm going to exit this. And then, what is weather mean? There we go. All right. So I'm going to see if I can get 2 things going here so that I know y'all can't see this, and I know it's going to be really hard, so y'all are going to have to, I don't know if I'm going to be able to go back and forth. We're going to try. We are going to try. But the first thing you see on your lab is, oh, you don't want to see my coffee cup. The first thing you see on the lab, I'm going to have to go back and forth. That's going to be the only way to do this. The first thing you see on the lab is, what is weathering, right? What is weathering? And it's asking you to state whether or not, yeah, I'm going to have to go back and forth. What is weathering is kind of the big question here, right? It's asking you which is stronger, wind or a rock. So which one do you think is stronger, wind or a rock? Jace, you think wind is stronger. So I'm going to write down which is stronger. I believe wind I believe wind Okay, I believe wind is stronger because wind doesn't blow the rocks. It carries what? What does it carry? We talked about this yesterday. Wind carries sand. Wind carries sand. Itty bitty sand that blows against the rock. I am going to give you 2 minutes less than 2 minutes. When you're done writing or typing this in, then go ahead and stand up so I know that you're ready to wash your hands. Yes, correct. Rylan, go wash your hands. Guys, you need to be at a level 0. You're at a level 0. We were in the class break. Okay. Then go ahead and line up. Then go ahead.
Go ahead and line up.
I was talking to Rebecca. Sadie, go ahead. So let's say you go after her. It was totally to do what you requested. But thanks anyway. Natalie, go ahead. Rylan, you need to go line up and take your time hold. I'll take that. I've got like 3 of you talking to me. Your lab. You're not done yet. Crystal, go ahead. Did you already wash your hands? Go ahead. Once you're done washing your hands, you go line up. Layla, go ahead. Miley, go after Layla, just fast line. Go.
I need one because I don't have one. So, where did mine go? I did have one. Must have given it away. No, it's not at all.
That'd be like a 2-hour video.
My computer won't hold that much. Alright, so I'm going to show you how to draw a picture, but first I'm going to show you that your cup of salt is the wind. Your chalk is the rock. Your cup of salt is the wind. Your chalk is the rock. So hang on a second. Do not eat it. You are in a science lab. You do not eat in a science lab. It might. So, the chalk is the rock. So what does that look like on your lab sheet? Let me show you. What that looks like on your lab sheet. Let me erase this. Okay, so what this looks like on your lab sheet, I'm going to draw my cup. And that is a cup. I'm going to label it because it says draw a diagram of the experiment and label the parts. So this is a cup. You do that. Put some sand in here. Guys, you don't have time. I'm not sand. Salt. Salt is also wind. And then I'm going to draw a piece of chalk in here. And my chalk is my rock. Chalk is rock. I'm going to give you a minute to do that. Set timer for 1 minute.
Okay, 1 minute and counting.
Guys, you were supposed to be drawing this in. Did you draw it in? It says draw a diagram of the experiment and label the parts. Yes? Alright. So now what you are going to do is you're going to take this, and I'm using the fat end of the chalk, putting it in the salt. For 1 minute, you're going to stir vigorously, okay, like this. Stir vigorously for 1 minute. Are you ready?
No.
Set timer for 1 minute.
Okay, 1 minute and counting.
And go. 1 minute. Stir vigorously. Without spilling. Do not puncture the cup. Stir vigorously. Without puncturing the cup. Keep stirring. Keep stirring. You're not doing the lab correctly if you're not stirring. Stir vigorously. Vigorously. Stir, stir, stir. I know, your arm's going to get tired. It's a good thing we're only doing this for a minute. Stir, stir, stir. Keep stirring. Stop, don't stop. Keep stirring. All right, stop. 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 So take a look at your salt. Did it change colors? It should have changed colors. If it didn't, you were not stirring vigorously enough. Did your chalk change? Yes. The answer is yes. If yours didn't, you did not do it enough. So, well, and that was the reason why I switched colors, is so that you could see. Some of you are still doing it. If you choose to still do it, that's fine. But we do need to finish this before we move on. So, write your procedure. What did we do? We stirred.
For a minute, probably first. No, that's how much.
We stirred the chalk,
Is this tape?
which is the rock. Are you writing this? In the salt for how long?
A minute.
For 1 minute.
It felt like a minute and 30 seconds.
Felt like forever.
It felt like
What was the result? Was the wind stronger than the rock? The salt, yes. Yours should have changed color. Hey, stop stirring. Start writing. Now, what color was it before? So it was a light blue, so you got to choose color. You can in just a second. We need to get this done first. So, then record the results that you had. The result was the salt changed colors. So the salt, which is the wind, changed colors. And the chalk okay? You and chalk? Really? Alright, well, I believe you. I'm the worst at spelling. Let's not talk about it. I got it. The salt wind changed colors and the chalk. Now you. Oh, yep, that does look right. The chalk changed shape. Or it broke apart. Now, we need to go ahead and start cleaning up. We need to get this done. Submit. When you are done and you submit, please stand, pack up, and stand to the right of your desk. And spell chalk right. Don't spell it like I did.